Hi. Thanks, Charlie. So I'm going to stay kind of at a higher level here than maybe the first round of speakers, and just talk today a little bit about New Hudson Facades and developing a bit of a culture that allows technology to play a major role in growing a company kind of from nothing to where you'll see we are today. So if you're not familiar, New Hudson Facades, the company was founded about 5 years ago to do the curtain wall on the Hudson Yards project, just up across a couple blocks away. So we as a company essentially just do curtain wall. So we start and do design with architects and building owners, work all the way through fabrication, assembly, manufacturing, and then do the installation. So a fairly vertical company, and that was one of the things that really sort of attracted me to come to the company. Is when you have that breadth of work and responsibility, you have the ability to make a lot of change and impact using technology, workflow, process. So hopefully today I can talk a little bit about how we do that, that maybe will lead you to think about how you do these things at your own organizations. So back in 2014, this is kind of where we started. We bought a piece of land off of I-95 just north of Delaware. And within a year, we had a brand new sort of facility up and running. So in this building, we have our sort of design and engineering teams, purchasing, manufacturing. On the back half of this is the facility where we produce all of our product. So we're located in Linwood, Pennsylvania, just north of Delaware. We've got offices kind of all across the U.S. We've been doing projects across the U.S. in the last 5 years. And part of the challenge of that in 5 years is going from about 10 people to about 350. So very quick sort of growth, but we needed to sort of grow at that pace and that speed to be able to support all the work that we kind of had lined up from the start. So the first project that we ended up working on was really what we call like a starter project. And we had 2 of these kind of lined up. So we were doing the design and engineering before we had that factory built. So this project's in Washington, D.C. I'm not going to go into too much detail about the projects themselves today, but just to kind of show you the type of work that we're doing. But what I do want to talk about is what it means to sort of design, manufacture, and install projects like this. So this is a fairly modest building in terms of height, 13 floors. It's about 130,000 square feet of curtain wall. And then as you sort of break it down into the design data, right, the thing that allows us to build, manufacture, and install that project, you get into about 67 dies. So, you know, what Justin just talked about, right, there's a significant cost associated to making all of these extrusions that come together to build unitized curtain wall. So that's kind of what you see in the background. You know, this project still, again, you know, over 500 shop drawing sheets and almost 4,000 unique part and assembly models. So at the same time, we're working on a project right off the High Line up by the Hudson Yards. It's One Hudson Yards is the name. A little bit taller building. Again, we're kind of in that same range of data being produced to do a project like this. So not a terribly complicated building, but you know, a building of scale. So we're in that 3,000 sort of unique part and assembly models being created. And we're doing this all within, say, the first year and a half of the company's existence. So how do you get to that point, right? And I just want to talk a little bit about the process of making those models, doing that design and engineering work. So as we talk about how we grow as an organization, how do you continue to be able to do those things and expand? So our process is not terribly complicated. We start out at a very granular level and we kind of build everything up. So you're designing dies that come together to form curtain wall panels, which you produce the shop drawings, and many of you have probably reviewed shop drawings at some point. Painful process, we're the ones that generate them. Then you sort of jump from the shop drawings into part models, and those part models are really the things that are going to drive CNC machines, procurement processes. So you're kind of making the 3D and you're loading it up with a lot of data. And then all that sort of comes together as assembly models, which then are used to figure out how you're going to build it on an assembly line. So once we get to that assembly model level, we're kind of looking back at the whole building, and then we're doing derivative design. So, this is where your automation, your scripting, your programming sort of comes in. You sort of build building blocks, and you find ways to work through them very efficiently. Out of that comes the data, right? So as a company that not only is doing the design and engineering, but we have to procure the parts and pieces, we have to manufacture some of those parts and pieces, we have to put it all together and put it on the building, the data is really what drives. So we take all of that information, right, and we got to stick it into a box, right? Somewhere you have to hold and house and maintain and store all that information. So the ability to manage all that information drives this kind of mess that is everything downstream of design and engineering, right? So you have to be able to schedule when you're going to make this stuff, how you're going to make this stuff, where you're going to make it, and then consume, manage, and maintain all of that inventory all the way till the product is on the job site. So from a data standpoint, that box is really important, right? Everything that goes in there and how you utilize that box is a significant driver in the ability to kind of do this work well. So on our first couple of projects, our starter projects, this was our box, Windows Explorer, some obsessive compulsive folder structures, and a whole heck of a lot of Excel. Pretty quickly, you know that's probably not the right solution, right? And there's a number of options, and I'm not going to get too much into the weeds about vetting out those options, but we ended up going with this idea of, okay, this is where we're at. We've got a pretty dumb box, and this is where we want to go as a company, right? First 2 years, our complexity and quantity level of what we're generating is not that high. Our ambitions are far greater than kind of where we are at that moment in time. So how do we start to develop a solution? How do we start to develop a mindset and a process that can support sort of growing that curve? So we sit down and we think about, okay, what matters here? Can we get lifecycle management? Can we have revision control? How do we make sure the right person's accessing the right document at the right time? Where can we start to standardize things? How can we automate more parts of the process? So what we ended up going with is a off-the-shelf Autodesk product called Autodesk Vault. Not terribly used in the sort of architectural industry, but pretty popular in manufacturing. And it, out of the box, gives you a lot of those features. You can start to link files together, control revisions, check things in and out for permissions. It's giving you backups of all of your data, and it gives you a nice place to actually visualize and find all the metadata associated to every part and piece. So we jump right into our sort of next round of projects. We'll call this kind of project cycle 2. So this is us finally starting to really work on the Hudson Yards project. So 55 Hudson Yards by KPF. Building is kind of anchoring one side of the Hudson Yards. Big jump up in terms of scale and complexity, in terms of the amount of models, data that's being produced. So we go from about 4,000 part models in those previous jobs to 14,000. And these are just the actual raw file, not the step file that's produced for the CNC programming, not the part drawing that's used to do quality control or send out to a vendor. This is just the first base level file. We're jumping up drastically in terms of the amount of documents being created. Concurrently, we're working on 15 Hudson Yards, which is with Dale & Scofidio, curvilinear building, so this is going to skyrocket that number. So pretty challenging building in terms of complexity of curtain wall panels. So we hit the 30,000 mark in terms of models generated for this particular job. So again, this one's a heavily automated process versus a little bit more of the brute force, put your head down and model away. And at that kind of moment in time, as a company, as an office, as a group of individuals in the engineering and design department, we kind of stop and we say, we've got this solution that we've been using. We've been using it for about a year and a half on 2 pretty challenging projects, but how can we do better, right? Where can we find efficiencies? How can we start to extract the data out of this software that we're using to learn about our own process and then redevelop a new process? So we're doing this at a year and a half in from the moment of saying we've got a dumb box, right? So we're already a year and a half in thinking, how do we change this? How do we get better? How do we improve? So we go back to where we started. We ask a lot of questions, and we start to come up with solutions to fix some of the problems that we're seeing in our data. So we come back and we build a brand new vault, we customize it a little bit more, and we start thinking a lot more about that sort of tangled mess that's at the end of the design and engineering stage. We use an ERP system called Epicor. This is where the data ends up going for how do you buy material, how do you plan what's going to get made, what's going to get built when, where is it sitting in inventory. So how do we get that connection going? So as we build that new version that sort of takes on those challenges, we start working on 35 Hudson Yards SOM project, right smack in the middle of those other 2 towers. Again, not quite as complex as the Doran-Scofidio one, but we're still getting close to 20,000 models being generated in about a year and a half time. So things are very rapid. We start working on a project, 1500 Mission for the city of San Francisco. This one's actually in construction right now. So it'll be about 192,000 square feet of curtain wall, completed sometime early next year. 110 Wacker in Chicago, right on the river. This is a bit of a beast of a building. It'll be over 500,000 square feet of curtain wall. So again, we're getting into lots and lots and lots of projects. 18th Street is a Heatherwick project down at the end of the High Line that sort of features these bubble windows. Slightly smaller window project, but a lot of complexity in the formation of the curtain wall panels. And then 50 Hudson Yards, the last project that we're doing in the Hudson Yards by Foster and Partners. And this is by far the largest project that we're going to tackle to date, over 800,000 square feet of curtain wall, sort of running through our facility at the moment. So that's over the course of, I'd say, the last 2 to 2.5 years. We'll have over 2.25 million square feet of curtain wall and over 80,000 models created. So the ability to manage and maintain all of that design data and then be able to parse through it to learn from what you did is incredibly important. And whether you're sort of doing that through a custom application or something a little bit more out of the box, or somewhere in between, right? That's what allows you to be able to go from, a dirt pad with a brand new building, 5 years ago to being able to sort of produce buildings like this, is that ability to really think critically about your process and then continually try to improve it. So at this very moment, we're about to start projects in Los Angeles, Philadelphia, continue work in Chicago and New York, and we're staring at this curve again, thinking, how do we get even more efficient? So we're back at the drawing board again, asking more questions, thinking more critically about this process, designing a new vault, automating more, creating more customizations, using interoperability software to talk back and forth to our sort of manufacturing database, all in the while of saying, how do we continue to get better, right? So as a company that's 5 years in, we've reimagined our sort of file management structure 4 times, with lots of little jumps in between. And it's not necessarily the type of thing that freaks people out, right? It's actually part of the culture that you get so far and you immediately question and ask, okay, when are we gonna improve this? How do we get to the next step? And that's generally, the sentiment of everybody that works there. So as a company, we're not just doing this from a sort of design and engineering standpoint. We do this across the board. And I think that's really critical in the success of adapting technology to a business model, is making sure it's across the board, right? I think we all know there's sort of the digital specialist and then there's the designer, right? How do you get those two minds to always be thinking together, still allowing, separate skill sets, but have everybody be chasing that same sort of agenda of how do we improve the business? How do we improve our workflow? How do we improve the quality of what we're doing? So we see that in very small ways all the time across our business. So on the left there, you see a gentleman building a current wall panel on the assembly line. The current wall panels for probably about a year and a half were traveling down the line on these big, aluminum sleds, right? Because you got a lot of protrusions sticking off the bottom of these things. They're gonna bounce down the rollers. So you give them a nice solid surface. So about a year and a half into that process, we all sort of step back and say, this is crazy. These things are enormous. They take up floor space. They're a little dangerous. They're heavy. Can we do something different? So you see a prototype for what we call a ski. So the ski is a small little 3D printed plastic piece that snaps right onto the current wall panel. They now have these nice little carts. So at the end of the line, you put them under the cart and you roll them down to the beginning of the line. You've effectively just freed up, 3 times the floor space. They're safer, they're cleaner. So trying to find opportunities like this throughout the business model. So we use some pretty nice Fanuc robots to do some operations on the assembly line, primarily shooting silicone. So when we started, our silicone tips were what you see on the left, made out of steel or titanium. They're welded. The lead time for these things is 3 to 4 weeks. They don't really last that long, so you have a lot of money invested and a lot of time invested. We go to 3D printing our own tips. They're like 50 cents a piece. When you break one, you have another one. You can custom design them to give you different types of beads of silicone, shoot into different crevices on curtain wall panels. So it allows us to do the complicated projects in an efficient way by being able to customize the manufacturing solution at will. And then just to kind of close it, I mean, this idea really comes around by developing this culture, right? And in the top you see a little like Teams chat. So we actually have people that are continuous improvement specialists. Like their job 100% of the time is to help organize, maintain, and streamline improving processes, improving the work environment. So you see a schedule. I mean, the green projects there are in progress. The gray ones we've completed, and the blue ones are out. So it is very much part of the overall business culture to want to get better, to find opportunities to get better. And I think without that as a mentality, we wouldn't be able to do the projects that we're doing, and we won't be able to grow the way that we want to grow.